I am converting the whole chapter light into the form of question and answer, and this is part 3. In previous class, we made different diagrams related to convex lens, and there were 6 different conditions for the convex lens and 6 different types of image was formed by convex lens. Today I want to tell the same thing as a summary and I'll proceed this class. Okay, look at this summary of the nature of image formed by a convex lens. Now what is the summary? I want to say position of the object. According to this position, what was the nature of the image formed, and position of the image also. This was first condition in which object was at infinity and its image was found to be formed at focus. So we can say that when object is at infinity, convex lens forms real, inverted and highly diminished image at focus. Second case was when object lies beyond 2f, then what type of image forms? It was found real, inverted and diminished image, and the position of the image was just between the focus and 2f. Look at this is represented shortly here. And third condition, when object lies at 2f, then what is seen? When object is at 2f, image is real, inverted, same size and it forms at 2f on the either side of the lens. Now next condition, when object is in between f and 2f, then what type of image forms? Again real image forms, and it is inverted also, and it is magnified and it forms beyond 2f. Okay, now fifth condition, what was it? When object is at focus, then its image was found to be formed at infinity. It was real, inverted, highly magnified and it was at infinity. And last condition was when object lies between optical center and focus, then this is very different case. At this time image was found virtual, it was erect, magnified and on the same side of the object. Look at this 1, 2, 3, 4 and 5. These 5 conditions. In these 5 conditions, actually image was found real, and real image is normally inverted, but when object comes closer and closer to the lens, what is found? The image moves away from the lens. And there is one exception. In only one condition, the convex lens forms virtual image and erect image when object lies between f and o. This is the summary of the nature of image formed by the convex lens. There were 6 conditions and these 6 conditions are summarized in this table. Okay, now let's go to another. 28. Write down the rules of refraction of light through a concave lens with diagram. Now I am talking about concave lens. Concave lens, do you remember? This is thinner in the middle and thicker at the edge. Okay, these are the diagrams which represents the rule of refraction of light through a concave lens. Looking at this, we can say that a ray of light coming parallel to the principal axis appears to be diverged from the focus of the concave lens. This is first rule. A ray of light parallel to the principal axis of concave lens appears to be diverged from focus after refraction. Now look at this second rule. A ray passing through the optical center emerges without deviation. Now look at this another rule. This is third rule. A ray of light is if directed towards the focus, then it refracts being parallel to the principal axis. These are the rules with which a ray of light passes through a concave lens, and among these 3 rules we are using first and second for the formation of image by a concave lens. Okay, let's draw the image formed by concave lens. Draw a ray diagram to show the image formed by a concave lens when object lies at infinity from the lens. Write down nature and place of image. We can show this with the diagram like this. The ray of light coming from the object which is at infinity are taken parallel, and it is taken parallel to the principal axis, and ray of light coming parallel to the principal axis appears to be diverged from the focus of the lens. That's why both of them are diverged here, and they are diverging ray, they never meet in the really refracted direction. That's why when they are produced in the opposite direction, both of them appears to be coming from focus and they intersected at focus. Since they are intersected at focus, that's why image forms at focus, but really light rays are not reaching up to the focus. That's why this image is virtual. The image is virtual. We can write image is virtual, image is erect. Virtual image is normally erect, and image is highly diminished because it cannot be seen in this diagram also. It is very small, that's why cannot be seen in this diagram. And these are the nature of image and place of image or position of image. Image forms at focus on the same side of the lens. We can write the meaning of the symbol also. F means focus, AB is object. Now next question, question number 30. Draw a ray diagram to show image formed by a concave lens when object lies between infinity and optical center of the lens, and write down nature and place of image. For this we can draw this type of ray. Here what is told, the object lies between infinity and optical center. Here we have optical center and infinity very far distance, and any place we can put the object. I placed at this position, this is the object AB, and a ray of light coming from the head of the object taken parallel to the principal axis, and it diverges from focus like this, and a ray of light passing through the optical center passes straight without deviation, and both of them are not intersecting in the really refracted direction. That's why this one is produced backward, and produced rays are always shown with the dot line, and this we don't have to produce. They appears to be intersected at this point. Since both the rays of light are not intersected at this point really, and image is seen, the light rays are not reaching up to the image. The light ray coming from the head is intersected at this point. That's why head goes up and the image is erect. This is virtual and erect image, and it is smaller than the object. That's why we can say this is diminished image. All this comes under the nature of image. 1. Image is virtual, image is erect, image is diminished, and position of the image is image forms on the same side of the lens. We can write the meaning of the symbol also. F focus, AB object, A dash B dash image. Okay, now let's go to another question. Write down differences between convex and concave lens. There are many differences. Few of them are here. Convex lens, concave lens. The first difference is definition. It is thicker in the middle and thinner at the edge, but concave lens is thinner in the middle and thicker at the edge. And convex lens, it converges the rays of light which falls on its surface, but concave lens diverges the rays of light which falls on its surface. Third, it forms different types of image, that is real, virtual, or maybe erect or inverted, or maybe magnified or diminished, etc. But concave lens always forms virtual, erect and diminished image on the same side of the object. Next, its principal focus is real, because really refracted ray passes through the focus. But its principal focus is virtual because really refracted ray never passes through the focus. Its focal length and power is positive. Convex lens has positive focal length and positive power. Its focal length and power is negative. And another difference, it is used to correct an eye defect called long-sightedness or hypermetropia. It is used to correct an eye defect called short-sightedness or myopia. Later we'll discuss about the short-sightedness and long-sightedness or myopia and hypermetropia also. It comes in the same chapter, light. Okay, let's go to the next question. Why a convex lens converges the rays of light? Write down with a diagram. Now, how can we draw the diagram? Look at this. A convex lens can be considered to be made by using different pieces of prism. If the lens is cut down into different pieces, I mean to say, we can imagine this way. If it is cut down, convex lens is cut down into different pieces. Each of the small piece represents a prism. And all of we know that when light falls on one of the surface of the prism, it always bend towards its base. Here also bend towards its base, here also, but the central part seems to be a glass slab and light passes straight through it. Otherwise, here this can be considered as a piece of prism and base is turned towards upward. And here base is turned towards downward, but here bases are turned towards upward. And when the ray of light coming parallel to each other, when falls on these pieces of prism, all the prism bend it towards its base and they turn towards the principal axis, and this is the action called converging action. Okay, we can describe like this. A convex lens is considered to be made by the combination of the pieces of the prism. Pieces of prism are combined in such a way that their base is turned towards the principal axis. Since a prism refracts the rays of light towards its base, so the light rays falling on the entire surface of the lens turn towards its principal axis. Hence, it converges the rays of light. This way we can answer. Okay, now next question. Why a concave lens diverges the rays of light? Write down with the diagram. This is the diagram. If we consider that a concave lens is divided into different pieces, then each of the piece represents a prism except the central piece. This can be considered as a prism and the upper side is its base, and this also in this three prisms the base is at the upper side, but in these cases the base is towards downside. Okay, in the middle, in the central part, we can say that this is a glass slab, and if a ray of light enters into it through normal, it passes straight. Okay, all of we know that the prism bends the light which falls on its surface towards its base. That's why each of them from above this principal axis, each of them turn the light away from the principal axis, and at the downside also each of the prism are turning the ray of light towards their base, and that's why each of the ray of light is moving away from the principal axis. This is called diverging action, and we can answer this way. A concave lens is considered to be made by the combination of the pieces of the prism. Pieces of prisms are combined in such a way that their base is turned away from the principal axis. Since a prism refracts the rays of light towards its base, so the light rays falling on the entire surface of the lens turn away from its principal axis. Hence, it diverges the rays of light. Okay, let's move to another question. What is power of lens? This is a little different term, but what is exactly the power of lens? The converging or diverging capacity of a lens is called the power of lens, or it can be defined this way also. The reciprocal of the focal length of the lens is called power of lens. It can be represented by formula power of lens P equal to 1 by focal length small f. Now, another question, what is the SI unit of power? SI unit of power is diopter. Power is measured in diopter. It is in the name of the scientist. What do you mean by 1 diopter power? We can answer this way. Power of a lens is said to be 1 diopter if its focal length is 1 meter. Very simple. Now next, what is magnification of a lens? Magnification means what? The ratio of height of image to the height of object is called magnification of the lens, and it can be represented by this formula: magnification equal to height of image upon height of object, m equal to I by O. Or we can write this way also: the ratio of image distance to the object distance is called magnification. There are two different definitions, both can be written, and according to second definition we have this equation: magnification m is equal to image distance by object distance. These equations are used in the calculation. According to the given information, if height of image or height of object is given, then we'll use this formula to calculate magnification. And if image distance and object distance are given, then we'll use this second formula to calculate the magnification. But exactly what do you mean by the magnification is 1? If someone says magnification produced by this lens is 1, what it mean? It means very simple. It means the ratio of height of image to the height of object is 1, which means the object and image is of same size. If magnification is 2, then height of image is 2 times greater than that of the height of object. Okay, now let's talk in detail. Magnification is exactly ratio of height of image to the height of object. But why it is written that it is the ratio of image distance to the object distance? Why this second definition is taken? It can be answered this way. Prove magnification m equal to image distance upon object distance. How can we prove? Let an object AB is placed in front of a convex lens. Its image A', B' forms behind the lens. We have done this many times. We can consider like this. An object AB is placed in front of the lens and its image formed behind the lens. Okay. Now in the triangle OAB, here OAB is a triangle, and triangle OA'B', OA'B'. In these two triangles, angle AOB is equal to angle A''OB'. Angle AOB is equal to angle A''OB'. Why? Because they are vertically opposite angle. Vertically opposite angles are equal. Now next, angle OAB is equal to angle OA''B'. Now next, angle OBA equal to angle OB''A'. Angle OBA, this angle is equal to angle OB''A'. Because this is the remaining angle of the triangle. If two are equal, third is remaining angle of the triangle are equal. Okay. Now next, therefore triangle OAB and triangle OA''B' are similar. OAB and OA''B' are similar triangle, because 3 angles of one of the triangle is equal to 3 angles of another triangle. Okay, the ratio of one similar side is equal to the ratio of another similar side in the similar triangle. In case of similar triangle, the ratio of one of the similar side, let's say AB and A''B', they are similar side. In the same way, OA and OA' is another similar side. In the same way, OB and OB' is another similar side. The ratio of one similar side is equal to the ratio of another similar side in the similar triangle. That's why what can we say? Therefore, A''B' upon AB, the ratio of these two similar side, this and this, these two similar side is equal to ratio of these two similar side, this OA' upon OA. The ratio of one of the similar side is equal to the ratio of another similar side. That's why A''B' upon AB is equal to OA' upon OA. Now we can write this way: A''B' by AB is height of image upon height of object. A''B' is height of image, AB is height of object, and this is equal to OA' is image distance. Here it is. OA' is image distance, but OA is object distance. Now what can we say now? Height of image upon height of object is magnification, and magnification is image distance upon object distance, because magnification equal to height of image upon height of object. That's why lastly it is proved that magnification equal to image distance V, it is represented by V, upon object distance it is represented by U. This way we can prove that magnification equal to image distance upon object distance. Otherwise, magnification is equal to height of image upon height of object is the real equation formed by the real definition. Thus, it is proved. Okay, this much for today. I'll come back in another class with more information about the light. Okay, I want to stop now.